Okay, continuing today to work on hyperbolic trig functions. I just wanted to do a few integrals, and we have here on the board the integral of hyperbolic cosecant of x dx. Okay, now to get started with this one, I actually want to do this using kind of a trick, and I don't actually really like this method because it kind of requires you to know the answer before you do the problem. What I'm going to do with this actually is I'm just going to multiply by 1 by multiplying the numerator and denominator by hyperbolic cotangent of x minus hyperbolic cosecant x over the same exact thing. And maybe now you can see why I don't like this very much, because it's kind of like, how are you going to remember that, or how did you think of that? But all the same, I still want to go over it just in case you haven't seen this method before. So we'll just multiply everything out and we'll distribute this in. Now, of course, the denominator is just going to be this thing here, hyperbolic cotangent minus cosecant. And then multiplying in the numerator for the first term here, we're going to have, I'll write this as hyperbolic cotangent times hyperbolic cosecant. And then for the second piece, it's just going to be hyperbolic cosecant squared of x dx. And now what I want to do is I just want to do a u substitution, making my u the whole denominator. So we'll just write that down. The u is going to be this whole thing, hyperbolic cotangent minus hyperbolic cosecant. So now we'll go ahead and we'll take the derivative. The derivative of hyperbolic cotangent, that's just going to be minus cosecant squared x. These derivatives work basically the same way as like with secant and tangent, except with a minus sign in front. That's just how I remember it. And then for the derivative of hyperbolic cosecant, this is going to be minus, which I'll change this to a plus, cosecant x times hyperbolic cotangent x. And we'll bring a dx down here. And the thing to notice is now our du value, this is actually just our whole numerator. So this thing just reduces down to just du over u. We'll integrate that and we'll get the value, natural log, absolute value of u. We'll just go ahead and we'll back substitute on this. And so for our final solution of this, we'll just have natural log, absolute value, hyperbolic cotangent minus hyperbolic cosecant, add a plus c, and that's it. And again, you can see it helps to know the answer before you do the problem, because if you knew the answer, then you can just multiply it by 1 by multiplying this in the numerator and denominator. So that's the method. We'll do some more on this in the next video. Thanks everyone for watching. Have a good day.